So let's read this problem. It says f is a differentiable function such that f of x is equal to x for x belonging to this interval. Also f of 0 is 1. We have to find the value of this integral. Now here, to begin with the solution, you will need to observe something here. What do you think, what can we do here? A quick and I would not say too easy, but yeah, reasonable observation here is to substitute x equals to f of t. Why? Because if I do that, you see my function, if I do that, you see my integral, substitute x equals to f of t, f of t 2016 dx. This will then come out to be t using this, well, not here, this will be f of t, this will be t, sorry, 2016 dx. So you see my integral has not changed at all. I began with this and I still have this. Well, here I would have something else in place of dx, of course it would be something in terms of t, but this term here, right here, this did not change at all. It is same. So with this observation we will begin, we will try to think whether this substitution is good or not. I just gave you the reasoning how I came up with this. I was quickly able to observe that if I do the substitution, this term here remains unchanged. So that gave me a sort of courage to do this substitution. Alright, but to begin with this substitution, we will need to know whether f is monotone or not. And this is something which would only good students will know, that we cannot substitute anything. We cannot take x to be anything. We can take x to be only those functions of t which are monotone. In the theorem where we change the variable in integration, you might have studied this. The substitution have to be monotone, strictly monotone. Alright, so we can only do this substitution if we can somehow show that ft is monotone. Alright, so how can we do that? We'll do that using this. Okay, we know f is differentiable, so it's continuous. Yes, and when we do this substitution, we would also have to do this, right? Dx is equals to f dash t dt. This is how we would replace, this is how what we will replace dx with. Here dx we will replace with this. But to be able to do this, we also need to know that f is differentiable, but which is given which is given in the problem itself, that f is differentiable. So we don't need to worry about differentiability of f. Alright, so let's see how can we show whether my function is strictly monotone. Okay, if we can show my function is 1 1, I am through. I have proved that my function is monotone. So let's try to show my function is 1 1. So say f of a is equal to fp, then I apply f. Of course a comma b belongs to this interval where, yeah, and I will apply f of a is f of b, which from this I get a equals to b. So it wasn't very hard, right? Implies f is 1 1. So proving that f is 1 1 wasn't really hard. Now since f is 1 1, implies f is strictly monotone. In fact, it is strictly decreasing, because we know function 0 is 1, and if I substitute x equals to 0 in this thing, I would get f of 0 is equals to 0, but f of 0 is 1, so f1 is 0. So function f0 is 1, 0 is 1, and 1 is at 0, so it's decreasing, you can see. So it implies f is strictly decreasing. Okay, now I think we are well settled to do this substitution. Okay, so let's begin with that substitution now. Well, I'll do x equals to f of t, and my dx would be then f dash t dt. Then I'll replace. Now this is a standard procedure from here on. Before I begin, I would want to take this to be I. Take it to be I equals to this. I want to know the value of I. Okay. Now I have my I equal to this. When x is 0, then t is 1. So here the limit will be 1 to 0. Now my x is f of t. Oh, sorry, you couldn't see. So I just change the limits. What would be the limit? It would be 1 to 0. Using this and using these limits I got. Alright, so f of t minus f of t 2016. There's nothing special about 2016, you can see here. It could have been any even number. Then dx would be f dash t dt. Then this would become, when I will flip the limits, I would have to take minus sign out here. And now just a sec. I would, this thing will become t, so I'll write this in this way. Since the power is even, I can do this. And I have this thing. You'll see why I flipped. Why I didn't write ft minus t. Why I had flipped it. You'll see in just a sec. And this is my I. So this is I, and right here this is also I. In this I we just made substitution and we got this. Now what I want to do is I'll add both these I's. So I want to add both of them, and you will quickly see why I want to add. It was just a small observation that I was able to make, and I would have integral 0 to 1 t minus so I'm writing this I first, and since x is just a variable, I can write t here in place of x. Okay, changing the variable doesn't affect the integral at all, definite integral at all. So I have x minus fx, so this dt, and adding the original I to this I would have minus 0 1 t minus ft 016 f dash t dt. And you see I can take these things common. I would then have 0 to 1 t minus ft 2016, and in here I would have 1 minus f dash t dt, and this is all equal to 2i. And you see why I added these two i's now, because this thing is the derivative of this function t minus ft, not taking the power. And from here on I will do one more substitution, and the substitution would be, I'll take Okay, so continue. So to continue with the problem, we'll make substitution now, and the substitution that we'll make now is this: t minus f of t. We'll take it to be y. And before I show it to you that this is a valid substitution, you know the condition for valid substitution, right? I can substitute in the theorem. You have seen it itself. I can substitute t as phi of, say, w. I can substitute this and it's valid if my phi is monotone, right? So how do we know that this is a valid substitution? Well, I'll tell you how. But before that, I want to tell you that I knew phi is f is monotone, and I also know f of 0 is 1, f of 1 is 0. Combining these two information, this one and this one, I can imply that my function is decreasing. It's strictly decreasing, and since f is strictly decreasing, I say minus f is strictly increasing. And I also know that x is strictly increasing, this function, so their sum would also be strictly increasing. So I've just now shown that this function here is strictly increasing, and this fact will take care of our little condition here, that does this function, how this substitution is valid. The fact that this function is monotone take cares of this condition right here. Okay, and how, if you wish to know how it take cares of this, well, I'll explain this to you once I've solved this problem. Okay, so I'll tell you how the fact that this function is monotone take cares of this condition of ours, how it shows that this is valid substitution. Okay, I'll do that once I'm done with this problem. Okay, it's not much left here. Since this substitution is valid, I can now, if I differentiate it, I'll be left with this, and from here on it's easy, right? I'll have dt here as well. So now if I proceed, I will have the integral will convert to minus 1 to 1 y to 1 by 16, and it will be dy. It's basic calculation now, just doing this. Here it will be y, so I have y to the power 16. These limits will be converted to minus 1 to 1, and this thing is substituted with dy, which I've got here. So nothing too fancy going on here, very simple, basic, and it's just easy to evaluate. This will be y 2017 from 1 to minus 1. This will come out to be 2 this, and do you remember that we were calculating 2i, not just I? So this whole thing was 2i equals to, so 2i is equals to this, and then my I will come out to be 1 by 2 parts. That's my answer of the original problem which I wanted to calculate. I've got this. Coming back to how this, the fact that this is a monotone function implies that the substitution is valid. How do we know that? Okay, so to show that, what I'll do is I'll take this, I'll write it here, y is t minus ft, and I can also, y and g of t is same. Okay, how, well, you must have seen in previous classes, you write y equals to 2x plus 1. We can also write this as f of x 2x plus 1, right? The same thing going on here. Okay, so I know that this is bijective, is strictly increasing, and if we define it on an appropriate I don't know domain, this can be shown to be bijective. Okay, so this is f of t, some function of t. Now, well, not bijective, forget about bijectiveness, we just need it to be monotone. It's monotone, so this is monotone, and since it's monotone I can take the inverse. So inverse of this, I can take the inverse of g. Since this is monotone, this is a monotone function in terms of t, so I can do this. So I will have t equals to some function in terms of y, and this would be the inverse of, yes. Now I can rewrite this in terms of, I don't know, t. Whatever here was in y, replace this with t. This would be this. Okay, I hope you are following. What I've done here is y is same as g of t, and this. And now what I've done from here on is, since g is, this is monotone, I can take the inverse. And when I try to do so, I'll have to take t here and I have to express everything in terms of y. This y was here. I've done this, and t can then be written as this g of inverse of t, and everything that was here in terms of y would be written as in terms of, yeah, t. Okay, so now since g was monotone, implies that g inverse is also monotone. But g inverse is, these are same things, so g inverse is same as writing t equals to a function in terms of y. So this is monotone, so this function right here is monotone in terms of y. So this substitution I will make. So at the end, the substitution that I'm making here is, I'm taking t to be this some function of y. And how will I get this y? From all this. Okay, so I've done at the end this substitution, t equals to this some function of y, and I've proved that this some function of y would be monotone, and hence the substitution would be valid. Okay, I hope you get it. If you don't, comment me down and I'll try to clear your any confusion that you have left. Okay, thank you. And just to add one more thing, well, these small points, the points where you tell or show in the solution that this substitution is valid, for the substitution to, why the substitution is valid, the fact that this is monotone, this thing, and this substitution right here, and you mention this substitution is valid because f is monotone. These are the sort of things that are checked in ISI exam. If you mention them, if you do forget to mention them, then they will take out some of the marks, and if you have do mention them, this shows that you have a real understanding of the subject. Okay.